Let me tell you another example to understand better of the specific heats and latent heat of fusions and latent heat of vaporizations. This is an example given here. Okay, take 1 kg of ice which is at minus 5 degrees Celsius and you want to convert it to vapor at 150 degrees Celsius. I have told you earlier that this conversion directly is not possible. It involves many steps. You can also write. Without watching my steps, just try. And to check, watch this video whether the written steps are right or wrong. See the steps. Step 1. 1 kg of ice at minus 5 degrees Celsius should convert to 1 kg of ice at 0 degrees Celsius. First step. Step 2. 1 kg of ice at 0 degrees Celsius converts to 1 kg of water at 0 degrees Celsius. See, ice to water, constant temperature. Now step 3, guess, you are at this state. Now take this 1 kg of water, what it has to do? 1 kg of water at 0 degrees Celsius has to change to vapor? No. It has changed to 1 kg of water at 100 degrees Celsius. Then, step 4. You can have a doubt. Why I'm writing water at 100 degrees Celsius only? Why can't I write 90 degrees Celsius? Why can't I write 110 degrees Celsius? Yes, there is a reason. 100 degrees Celsius is called boiling point of water. When water reaches to boiling point, then only it starts boiling and goes to vapor state. Similarly, why I'm writing ice at 0 degrees Celsius? Why can't I write 1 degree Celsius, 2 degrees Celsius? 0 degrees Celsius is called freezing point of water or melting point of ice. Ice has to melt, then it can convert to liquid state, and that melting starts at 0 degrees Celsius. That's what is called melting point. So that's why we are taking these are the limiting values: 0 degrees Celsius melting point of ice, 100 degrees Celsius boiling point of water. Now come back to step 4. Now step 4, 1 kg of water at 100 degrees Celsius. Now what happens? We want to reach vapor at 150 degrees Celsius, no? So 1 kg of water at 100 degrees Celsius reaches to 1 kg of vapor at 100 degrees Celsius. Constant temperature, change of state, liquid to gas. Then step 5, 1 kg of vapor at 100 degrees Celsius. See, this state I am written here. What will happen? Already is in vapor state, already is a boiling point, and we want this 150 degrees Celsius. So you have to increase the temperature, that's it. So it is 1 kg of vapor at 150 degrees Celsius. So this is how 5 steps are involved to convert from this state to the other state. Now here, in all these steps, the amount of heat energy is supplied. All this taking the amount of heat energy to move from one state to the other state, to change from one state to the other state. Let me check what type of state, what type of amount of heat energy here it is called. Here temperature increased. When temperature increased, the amount of heat energy is called specific heat or latent heat. Yes, you are correct. It is called specific heat. So this is specific heat. Here 0 degrees Celsius, 0 degrees is a constant temperature, but state is changed. So latent heat. But which type of latent heat? Latent heat of fusion or latent heat of vaporization? Solid to liquid. So it is nothing but latent heat of fusion, LF. Now here again, water at 0 degrees Celsius to water at 100 degrees Celsius. Water, temperature increased. what type of amount of heat it is? Yes, it is same, specific heat. Next, 1 kg of water 100 degrees Celsius, 1 kg of vapor 100 degrees Celsius. Temperatures are same. Liquid state, gaseous state. States are changed. So it is latent heat. But which type of latent heat? Fusion or vaporization? Obviously it's a vapor, so it is vaporization. Last step. Vapor, vapor. Temperature increased. So which type of amount of heat? Yes, it is correct. It is specific heat. So if I say this is the amount of heat energy used is Q1, amount of heat energy is Q2, amount of heat energy is Q3, amount of heat energy is Q4, amount of heat energy is Q5. So the total amount of heat energy Q equal to sum of Q1, Q2, Q3, Q4, Q5. So simply we say we are supplying amount of heat energy, but it's amount of heat energy used in 5 stages in different forms to get our required state. Now the question is that changing of states only for water, not for other materials? Yes, you have. You have change of states for other materials also, and already we have discussed that. Now, in the process of change of states, there are some factors which influence the change. Sometimes they will make the change little faster. Sometimes they make the change little slower. So what are those factors? Let us see. Factors affecting change of states. First one, temperature. Take a container filled with water. It's filled with water. Take another container filled with ice. Filled with ice. Now using Bunsen burner, heat the ice. Here also heat the water. So if you keep the ice without supplying any heat, of course it changes to water state, which is called liquid state, after some time. But if you supply the heat to this ice, means you are supplying the heat and you are increasing the temperature of the ice, then the change of water has been done quickly. That means when you increase the temperature of the substance, change of solid state to liquid state is faster. Here also same thing. The water has to convert into vapor state. So it has to vaporize. If you put the water in an open place, it has so much of time. I think it will take so many days to vaporize. But if you supply the heat to the water, it will vaporize in less than 2 minutes or 3 minutes. If you take 50 ml of water, quickly vaporizes. So here also what I want to say that if you increase the temperature of the substance, the change of state is faster. So rise in temperature will affect the change of state from one state to the other state. Now second factor, pressure. If you decrease or increase the pressure, there is any change of states? Just think, already we have discussed one example in the previous concepts. Yes, LPG, I give an example to LPG, liquid petroleum gas. So as I told you earlier, the gas is stored inside the cylinder in the liquid state. How they will store huge amount of petroleum gas as liquid state in the gas cylinder? They will apply high pressure to the gas and reduce the temperature. Then immediately the gas changes into liquid state and it will fill inside the gas cylinder. So the huge amount of gas can be filled in a small volume by applying high pressure. So using pressure also you can change one form of state to the other form. Take another example, CNG. Nowadays you're getting CNG cars. Compressed natural gas. Same thing, they take the natural gas from the environment, they compress it and fill inside the cylinder. So in that way, applying the pressure also, you can change one state to the other state. So we have two factors to discuss. One is temperature, other one is pressure, to change one form of state to the other form of state. Generally, if you see the ponds, or if you think about the ponds or the lakes in the Arctic and Antarctic regions, how they appear. You'll observe some ice sheets floating on the water, and inside or under the ice sheets you have the aquatic animals. So how on the surface of the lake the ice sheets are floating? How it is possible? Let me explain you. This phenomenon is called anomalous expansion of water. Anomalous expansion of water. Let me show you. So in the Arctic and Antarctic regions, the ponds, lakes filled with have water, but on the surface of the water you have ice sheets floating on it. Why the surface of the water comes in the solid state in ice? Okay, ice is at 0 degrees Celsius and say it is 4 degrees Celsius, and from 4 degree, 3 degrees Celsius, 2 degrees Celsius, 1 degree Celsius. So temperature decreasing and reaching to 0 degrees Celsius, because you know that ice is a solid state and existing at 0 degrees Celsius only. So generally what happens, whenever temperature decreases, the volume should decrease. But the peculiar behavior of the water, when temperature decreases, volume should decrease. But because of peculiar behavior of water, when temperature decreases, volume increase. From 4 degree to 0 degree Celsius, this behavior is only between 4 degrees Celsius to 0 degrees Celsius. Because of volume increasing. So when the water reaches state of 0 degrees Celsius, the volume is maximum. When the volume is high, what happened to density? Density is less, because density equals to mass by volume, inverse proportional relationship. And because the density is less, at 0 degrees Celsius, the ice sheets starts floating on the water. And this is what called anomalous expansion of water. And these ice sheets protect the aquatic animals inside the lake from the sun, from the sun's temperature. In the previous concept, I told you about specific heat and latent heat of fusions and vaporizations. In those discussion, I have mentioned a word called melting point, boiling point, freezing points. What are these points? These points are actually not points. These are temperatures. Let me tell you what these temperatures are. So number one, melting point. Melting point is nothing but it is the temperature at which solid melts into water. So the melting point, solid changes to water. Solid changes to liquid. Melting point. And if you take the example of ice, if it is solid state, to water, so it is the temperature at which solid changes to liquid. And the example of ice to water, the melting point is 0 degrees Celsius. Now, we have another point or another temperature, you can say, called freezing point. Freezing point means reverse case. Liquid converts to solid. So it's the temperature at which liquid converts to solid. Take example. Now I have water. I want to convert water into ice. So water liquid state, ice solid state, and that freezing point is also 0 degrees Celsius for water and ice. So melting point of ice or freezing point of water, both are same, 0 degrees Celsius. The third one, boiling point. It is also called vaporization point. Liquid to gas. No, you can give the definition. It is the temperature at which liquid changes to gas. If you take the example of water changes to steam, I can say vapor. So water changes to steam or vapor at 100 degrees Celsius. So 100 degrees Celsius is called boiling point. It is also called vaporization point. So in that way, for water you have melting point. Water means water, ice, steam. So you have melting point, freezing point and boiling point. So like the three different types of temperatures we have. Now I will tell you a very important point to you. At this 0 degrees Celsius, you are seeing two states, ice and water. Both states are existing. Ice, water you can see. Here also water and ice. At 100 degrees Celsius, you are seeing two states, water state which is liquid state, vapor state which is gaseous state. Two states. But there is a temperature at which you can see all the states at a time. That is the beauty of the temperature. All the states means water, ice and vapor. Solid, liquid, gas. All three states you can see exactly simultaneously. What is the temperature? That temperature is 0.01 degrees Celsius. And this is called triple point. Triple means three. Means you are seeing three states at the same time. Triple point. So 0.01 degrees Celsius is nothing but almost equal to 0 degrees Celsius. So if you keep ice on a table, understand carefully. Ice is solid state. Yes, you observed a solid state. But if you see the bottom of the ice, you can see some water at the bottom of the ice simultaneously, which is liquid state. And if you still observe carefully, you can see some vapor above the ice. So at 0 degrees Celsius, exactly experimentally they told 0.01 degrees Celsius, you have solid, liquid and gaseous state. That's why that temperature is called triple point of water. Now see on the board, you have different states. Let me explain you what is states. Melting. Melting is nothing but the state of conversion from solid to liquid. Ice to water. So when solid converts to liquid, that change of state is called melting. Freezing, reverse process. Liquid to solid. Water to ice. This freezing is also called solidification because you're changing to solid. That's it is also called solidification. Vaporization is nothing but liquid state to gaseous state. Water to vapor. Now coming to condensation state. Condensation, reverse process of the above. Gas to liquid. Condensation process. Gas means suppose you have water vapor, and when you take the heat from the water vapor, then the water vapor changes to liquid. Generally, you will observe this condensation process when you do hot water bath in your bathroom. Hot water is there, the bathroom is closed, all four directions closed. and you just bath completed. Now after completing your bath, if you observe the walls of your bathroom, you can see the vapor and some water droplets on the wall. So there, the hot water which you get the vapor state, that vapor converts into water droplets, and the water droplets you are observing on the walls. That's why condensation is called heating process, because the gas removing the heat from it to change to liquid state. Sublimation. Sublimation means it is from solid to gas. Direct, solid to gas, direct. Example, camphor, naphthalene, those are solids. And nowadays we are getting some other types of materials which gives scent smell in bathrooms, like odorel slabs. Those are solid state, but you keep it at one corner of the bathroom, and after 10 days if you see, you can't see any slab because it changes to gaseous state. And because it changes to gaseous state, you get the scent smell when you enter in the bathroom. So like, it's conversion of solid to gaseous state.